Welcome to the Tom Nelson podcast. Today I have Ronan Connolly here. He's a guest, a Twitter follower named Jim Husband recommended. Ronan, can you tell us a little bit about yourself, please?
Okay, I'm an independent scientist. If anyone's interested in all the details of my history and my experience, my personal website, like with a bio, is ronanconnellyscience.com. And it goes through my history on it. I think probably the relevance for you is that, and your listeners, is that starting around 2009, I was an environmentalist. I trained as a scientist. Okay. And so when I say I'm a scientist, the most common question I get is what type? I hope a good one, but it's like the for me, this is the problem, and I totally understand people asking this question. But science for me is multidisciplinary. It's not one subject. But over the last few decades, what's happened is that scientists, when you train as a scientist, you're encouraged to specialize and continually specialize and find your niche topic that you are going to be the expert on. And then you can talk about that one thing, and you know everything there is to know about this. And of course, the old saying is, master, you learn more and more about less and less until eventually you know everything there is to know about nothing at all.
Okay. So on my podcast, I think Willie Soon referred to you and your dad as geniuses. So I think I have a good feeling that you are a good scientist. But when you're ready, do you want to fire up the screen share?
Okay. So this is my website. You can just have a look at me here. There's me again. Don't need to look at me. I'm here already. So if anybody wants to see my qualifications, it's on there. And here are some of the papers that I'm doing on climate change. Around 2009, myself and my father, we were working in environmentalism, looking at developing sustainable methods of fish farming, wastewater treatment, and various other related topics like that. And people kept on asking us to comment on climate change. So we decided to start looking into climate change for ourselves, as from a not having really, just as an environmentalist would have had the same as any other scientist. So 2009, started digging in. Then by 2010, I was saying to Michael, there's something is rotten in the state of Denmark. I did not Denmark, we have Hamlet reference there. Okay. Something is rotten in the state of climate science, because what we were finding is that a lot of papers that were being published that were not very robust, and the results were not very robust. And we started to see that a lot of criticisms of what we knew about climate change, the popular narrative, were being unfairly dismissed and not really taken into consideration. So myself and my father, we said, let's try and look into this properly. And for ourselves, what's going on? We just wanted to know what was going on. So this started out as a kind of just in our spare time. And then we started finding results. And in the end, we started getting so many results, we realized we need to dig into this a lot before we tell anybody, before we do it. So we spent basically 4 years just checking, doing our own research, reading what other scientists were saying, and then trying to write up our own scientific results. And after a while, we realized that the amount of work that we were finding that was contradictory to, say, the UN Intergovernmental Panel on Climate Change, the IPCC reports, there was contradictory to that. We were like, across so many different disciplines, we were like, well, this is going to be very difficult to publish in one journal, in an article. We actually were finding, in the end, we ended up writing 8 detailed articles, which would be longer than most scientific journals were allowing. And we also noticed that each of the points that we were making in one of the papers, the criticism of it, because the conclusions went contrary to the what you're supposed to find, we realized that if we got that one paper published, that they would say, oh, you might have a point there, but this is contradicted by the overwhelming consensus on these other topics. And so we said, okay, we have to actually do, in the end, 8 different papers. And we need to, but we can't get those 8 papers published in any journal, because each journal would say, that's too long, it doesn't address that, it doesn't address that. So in the end, we said, look, the peer review system itself is not working correctly. And if we can talk, if you're interested, we can talk about
Sure.
what peer review means
Sure.
later on. But just to give your listeners and your viewers a bit of an understanding, we said, look, this is back in 2013-14, we said, why don't we just put all of our research findings onto the internet and ask the entire scientific community to see where we're wrong. And so we came up with this idea of open peer review, and we set up an open peer review journal where we launched our 8 papers, working papers. They're working papers. You can see we mentioned here non-peer reviewed draft, non-peer reviewed draft for most of these ones. One of them has been peer reviewed at this stage, but like most of them are there. And we just put up these 8 technical papers, and you can addressing various different things, like urbanization bias, is it a negligible problem? These are still on there. If people want to go, oprj.net, can still go there, and you can then download the paper, and you can, view it, and just to show people. Oh, sorry, that's not right. Okay, hold on. Yeah, this is it. These are detailed papers that are scientific reviews. And this like, we put far more effort into each of these papers than we did publishing peer-reviewed papers before. We knew these were controversial subjects, but we also said these are very technical. So we said, well, we need to do another. We need to do go to the globalwarmingsolved.com. We need to do something that's of more interest to the general public. So we have here. We only intermittently post this now, because mostly at the moment we're interested in actual scientific papers. But I would say if people are interested in our findings, particularly up to 2014, you can go to globalwarmingsolved.com, where we described and summarized our different findings there. Anyway, we launched that 2014, and this is like, we were not expecting it. The day after we launched the website, like made it live, within a few hours, it had gone, a few people had found it on Twitter or whatever. And so we had like hundreds of comments on like one of the more controversial posts, in which we're looking at the greenhouse effect or whatever. And we had like the things. So we ended up engaging on the blogs with people, back and forth, trying to get feedback. We, some of the feedback from both sides of, like, in terms of people supporting, say, the UN IPCC's conclusions, or it's worse than the IPCC concludes, or those that are saying it's critical or whatever, we had a lot of engagement at the time. Like, relatively speaking, we weren't expecting it. We hadn't even started promoting it, but within hours we were having all of these comments. A few people, and hit pieces. So within hours we had like a few hit pieces from bloggers, and actually a shout out to those hit pieces because they got attention to us. So, and then there's physics. There was a blog at the time. He was anonymous, pseudonymous at the time. But he's like a professor in astronomy in Scotland, and I haven't actually met him, but he actually, his hit piece got like loads of traffic there, and he wrote it. I don't know, he wrote it a few hours after we went live. And then there's another Dr. Victor Fenema, who I have met, nice guy, but he also is critical of the stuff. He wrote a piece as well. And then we had other of the, what you call the skeptical blogs, started commenting and saying, and so we ended up having a lot of discussion, which was very interesting, unexpected so quickly. But nonetheless, that led to that. Very little attention on the actual papers themselves. But what we did was we would started directly communicating with the scientific community, emailing them, asking them to, ones that had direct relevance, to comment on our papers and see where we wrong. And then we started like actually reaching out to people, and then visiting groups, trying to ask them off the record, on the record, to have discussions. Have we got anything wrong or whatever? I generally, the main criticism that we've had of the papers was that we got the wrong answer. But we didn't find any, we haven't, other than like a few minor tweaks here and there, nobody's so far, from talking at this stage now, talking to hundreds of scientists with expertise on specific things, and we haven't really seen any methodological flaws or things like that. But they were not peer-reviewed papers because they're working papers, and we asked the scientific community to do it. So the big criticism that people get, is now, oh, we're not going to look at that unless it's peer reviewed. Or we can talk about, does that actually mean anything later on? But because of that, we said, okay, right, we'll keep them there. People are welcome to go back to OPRJ to read the things, download all of the papers. People are welcome to go to the Global Warming Soft, which we still intermittently post there. But we started saying, can we start collaborating with different scientists to do further work, to hone in on individual aspects? So we started getting communication with a number of different scientists. One of them that we started working with was Dr. Willie Soon, who was at the Harvard Smithsonian Center for Astrophysics. And I think you've interviewed him already. So literally we had started working with him on a potential paper where we were finding a very interesting, we'd been looking at global temperature records, and we've been finding problems with what's called the urbanization bias problem, and we can talk about that if you like later on. But basically what we're finding is that the UN IPCC and a lot of papers have prematurely concluded that it's a real thing, but a small problem. And it's only a minor problem. And our work was showing that it's not a minor problem. Our work has continued to show that. And in fact, a number of papers increasingly are coming around to that conclusion. And in fact, even one of our 2015 papers, which I can talk about, the co-chair of the IPCC Working Group 1, Professor Panmai Jai, he actually, before he became co-chair, he cited our paper as saying, this is a concern we're not addressing. It's beyond the scope of this thing. But he said, but there is concern about the urbanization thing. So the IPCC, the co-chair, is aware that it's a problem. Apparently, the IPCC Chapter 2 authors are unaware of this. Okay, anyway.
Okay. I just want to make sure I understand you. Do you have any headline statement or summary about what you found about urbanization, or just that it's a bigger deal than the IPCC thinks it is? Or
yeah, we have several ones. In the Global Warming Solved, we have a post here. Let's see if you can just if you just search for urbanization. Let's see, it should be, there's that was our paper findings that we put in 2013, which is a summary. And there's a post there and people can do that. That was on our non-peer reviewed papers. So people would want to refer to the peer reviewed papers if you feel that magically, once it's peer reviewed, that then it's correct. But until then, it's false. Well, then, we can talk about that. So this paper here, this is the one that Padmay Chai referred to in his own work. This is 2015. This is reevaluating the role of solar variability on Northern Hemisphere temperature trends since the 19th century. And so this was the first collaboration that we did. This is with Willie Soon. Willie Soon is an expert on looking at the relationship of the sun and particular TSI on climate change. And we had been looking at the effects of urbanization bias and other problems, other non-climatic biases. And there's non-climatic biases that lead to a slight warming, and some that lead to a slight cooling. But we're finding that on balance, they're leading to a slight warming. And then there's another issue, which is related to what's called the temperature homogenization process. So this is a thing that about 10, let's say, really started the late 90s, but certainly since the early 2000s, all of the temperature data sets, the global temperature data sets, almost all of them homogenize their data to nominally to reduce the presence of non-climatic biases. So non-climatic bias would be if you have like a weather station and it's recording the temperatures, and then for like 20 years, and then you build a wall behind it, that's going to change the average temperature over the year. That wall will, right behind it, it'll change it. And depending, is it a south face, is it like a sun facing wall, or it might make it cooler, it might make it warmer, it might do both, at different times of the year. It might lead to so you can have these things there. Or another one is, say, a set of trees. This is a remarkably common problem, is that you will have around a temperature, or a Stevenson screen. Let me just show. Sorry, I use Brave. I'm going to go to Google in case anybody wants to follow along. Anybody that's watching. So if you look at the Stevenson screen, this was actually developed by this thing here. This is your typical average weather station. Okay, this is what has been used for like 100 years. So Stevenson screen was developed by Robert Louis Stevenson's father. So Robert Louis Stevenson wrote the Treasure Island, famous guide there. But his father, so in the 19th century, he invented this to try and shelter the thermometer, so that it wasn't randomly affected by rain falling on it, wind knocking it around and things like that, but that it was sampling the temperature. But you can imagine here, if you have like a Stevenson screen, you can see, you can just do the stuff. You see in the background, you have these bushes here, and you can have like trees in the background. This is a remarkably common thing. If you have trees behind it, if you set up your Stevenson screen, and in the background you have these trees, they start going in warming or like growing, then they might start sheltering the thing. And then people that are keeping it might say, oh, we'd better cut those down because they're interfering. So then you cut it down. So you have a bias, gradual bias from the trees gradually coming. Then you have an abrupt bias from when the trees are cut down. And then the process continues again. So that's like well-meaning, intention, you know, good work that people are doing. We'd better get rid of those trees because they're interfering. But it's now introducing a non-climatic bias into it. Then we have more insidious things where, for instance, you might have, like, this is one of the things that we touched on in this paper, the hazard reforestation thing. This was like the work of Anthony Watts around the time. He had kind of he'd organized in the US. There was like, at the time, there was a very large data set that it was very well kept. It's like called the US Historical Climatology Network. And it was 1,200 stations that had been handpicked to have long records, and it included urban and rural areas. It was like, to this day, it is probably one of the best networks for a nation, and a big component of the global data set. But even with those, you know, people, he asked them to do, like, start investigating these temperature weather stations, just going out and photographing what they are. And these are the results. This is from this, we used the data from 2011, and you could find some stations that were good quality or intermediate. This is a problem, slight problem, because often the distance you have like a car park, and that would change things, but it was far in the distance. But here you had one where you're like 10 foot from an air conditioning unit and a big tar macadam all the way around here. Now, and then you have this one on a roof. So he looked at, when they analyzed it, it turned out this is like the location of all of the stations that were there. These are the locations of the good quality, the best creme de la creme. You know, the excellent ones. These are decent, good ones. These are intermediate, you know, not brilliant. These are poor quality. These are bad quality. And this was a separate effect from the urbanization, because sometimes the stations that are very good quality are very good quality in the middle of an urban area. And then you have ones that are perfectly rural, right beside an air conditioning unit. So you have this mix. And by the way, you know, the dismissal was, oh, the US is just a small part of the, you know, of the globe. Yeah, but it just happens to be with the highest density of long temperature records going, which includes a large number of rural stations going back to the 1895 in particular. There was like the US co-op program started there. So these were the kind of issues that we were dealing with. Anyway, so I digress. Let's go back to the 2015 paper, because all of that was non-peer reviewed. So therefore, you know, don't mention it. It's irrelevant. We spent 4 years working on that. Far more than we did, you know, on the many peer-reviewed papers that I've done. You know, it's like, it was like we took a lot of care before doing it, but no, not peer-reviewed, so just working papers. But this is peer-reviewed in a high-profile journal, Earth Science Reviews. This was with Willie Soon. We just said, look, let's just look at two issues. The IPCC at the time, it was the fifth. So to your listeners, I'm sure quite a few of them are familiar with the UN IPCC. Okay, actually, that segues to, let's actually look at the IPCC. What is the IPCC? So let's go to, if we go to the IPCC, go to Google, go to ipcc.ch, and here we are. This is the Intergovernmental Panel on Climate Change. So what is the UN IPCC? What is it about? Well, let's go to About, the About page, and let's find out. The IPCC is the United Nations body for assessing the science related to climate change. That seems reasonable enough. Okay, fair enough. They provide regular assessments of the scientific basis of climate change, its impacts, and future risks and options for adaptation and mitigation. Now, at this point, I'll tell you, the IPCC divides itself up into 3 working groups. So working group 1, which is the one that I will be talking about, I imagine mostly, it's the one that I'm most interested in, is dealing with the scientific basis of climate change. And I think working group 2 deals with its impacts and future risks, and 3 is options for adaptation and mitigation. So that's what that means. That's 3 different groups. But let's just focus on the scientific basis. Anyway, what do they describe? How do they describe it? Created in 1988 by the World Meteorological Organization and the United Nations Environment Programme, the objective of the IPCC is to provide governments at all levels with scientific information that they can use to develop climate policies. Now, when I read that, I was like, for me as a scientist, it's like, that's a very odd remit. That doesn't seem quite right. Scientific information that they can use to develop climate policies. So it's like, is that what you would have thought was what their goal, when they meant to assess the science related to climate change? Okay, it's an assessment. They're specifically looking at scientific information that governments at all levels can use to develop climate policies. Now, what does that mean? Well, 2 + 2 = 4. That's scientific information. Okay, 3 × 2 = 6 is also scientific information. So they're looking and seeing, is that a bit of scientific information that they can use to develop climate policies? If it is, they'll provide it for you. If the scientific information is not useful for developing climate policies, they don't bother with that. They're not interested in that. Okay, that's my reading of that. Now, maybe other people read that and they will get a different interpretation. A lot of people have gone to this and said this is very important. This is a very good scientific body that provides a lot. I've heard people saying this is the climate Bible. This is the gold standard on climate change. Although, I think they mostly abandoned the gold standard a few decades ago. So the literal gold standard, maybe we should bring it back. Some people might argue that. But anyway, so this is the IPCC. Anyway, so if people are interested in the IPCC, oh, and by the way, this is on YouTube, you should mention that a lot of my work disagrees with the IPCC, and YouTube have like restriction. They're saying it's part of their thing. If something disagrees with, in particular, the IPCC, that this should be expressed, it should be made clear. So to make it clear, a lot of what I'm finding disagrees with the IPCC and maybe might not be as useful for developing climate policies. But let's look at this. So this was the 2015 paper. And what we just did was we looked at the IPCC 5th assessment report that was published 2013-2014. They had they had concluded on the basis of comparing computer model hindcasts, okay, technical terms, sorry for the jargon, these are the jargon that's doing it. A hindcast, you can imagine a forecast is when you're predicting what will happen in the future. So forward, hindcast. Hindcast is where the computer model, they'll get their computer model that makes predictions about how we're all going to die over the next 100 years. Well, most people will die over 100, but I mean from climate change or whatever. They go back, they get the models and they rewind their simulation and they run it from, say, 1850 up to present. And they say, what should have happened? What should have happened? And then they compare it with their global temperature things and say, yeah, it's about right. So our models are working. That's it. And what they do is they said, we ran our model using using natural forcings only, which they define as only considering changes in solar activity, total solar irradiance, a specific aspect of solar activity, and volcanic eruptions. And they use these data sets for total solar irradiance, TSI, solar activity, and one for volcanic. And they said, when we run that, we get up and down, but after around 1950, it slightly decreases. But global warming has been increasing. And then if we add in anthropogenic forcings, anthropogenic, by the way, you'll see that a lot, is man-made, anthropo and genesis, man-made. But if you said are human-caused, but if you say that, it doesn't sound as sciencey, so everybody calls it anthropogenic. So we use the term anthropogenic when they add in their anthropogenic forcings, which they've 2 natural forcings and they've about 24 anthropogenic forcings, and pretty much all bar one of them goes up and away, and it gets hotter and hotter and hotter. And they say, well, if we just do natural only, we can't explain any of the warming after about 1950, 58, after 1950s. But if we include the anthropogenic, we get lots of warming. So therefore, most of the warming since the 1950s is due to human activity. That was what the IPCC Fifth Assessment Report concluded, and apparently that was scientific information that governments at all levels could use to develop climate policies. But we were looking at is there other scientific information that might be of interest to the scientific community? Because I'm a member of that, and maybe other people, maybe even governments might be interested in that. So we said, okay, how did they do that? So we noticed 2 problems. First, they were using particular estimates of total solar irradiance, solar activity, that the data sets, they had 4 at the time, now they're down to 1. But there was lots of other ones in the literature, in the scientific literature. When we say literature, that's the thing. All the peer-reviewed publications is referred to as the scientific literature, or literature for short. If you look at all of those, there were other data sets that they weren't considering. And then the other thing is that we were finding that the urbanization bias was a lot bigger of a problem. So we actually went and said, oh, can we look at rural only stations? So I'm going to talk about, since 2018, I've been working full time. We set up a group called the Ceres Center for Environmental Research and Earth Sciences. Our team is like Willie, soon, and then it's my father. We have a couple of other people that are working with us, but we're the main ones. And if anybody wants to support us, please do. You can donate here, and it would be very appreciated. And just so that you know, because as soon as you say funding, people are like, oh, okay, this is a thing. In our view, scientific research works best when it is independent from industry, government, religion, politics, or ideology. This is our personal opinion. For this reason, strict requirement is that you cannot influence either our conclusions or research directions of our group. We basically, what you will be doing if you donate to us is you will be helping us continue to do what we're doing, which is to follow the science where it's leading. Now, that's not going necessarily going to provide governments with scientific information they can use to develop climate policies, but it is, we think it's important, and it's something that we're doing. So if we go to, you can see some of our work here. So we were talking that 2015 paper. So I'll just show you the finding that we had, and you can read the full paper. But basically, this is the IPCC. I talked about what they call their detection and attribution thing. This is for what they say the global temperatures have been since 1880. And this is what the models say. This is the mean of all of the CMIP5 hindcasts. And there's like technical statistics, but it's just to give a simple thing. You can see why they're saying it goes down, it doesn't keep warming. And so they said, oh, you can't explain any of the warming from about then onwards. It must, but then when you add in the human factors, you can explain it. And in fairness, that is kind of similar to that. And it's not at all similar to that. That's the IPCC. Well, this was their 5th assessment report, was the most recent at the time. It's get a similar result for the most recent report. So we just said, yeah, but you're using urban stations as well. So we came up with a new estimate. We said, can we identify regions which had like mostly rural stations and try and use them? And this is what we got. Instead of this is what we got. Now, I like the audio listeners that might not be seeing this, you can look it up yourself. But basically what we found is that in the urban and rural composites, which is the global warming that everyone goes on about, they have like basically 1880 is relatively cold, and it starts warming up until the 40s, and then it's kind of flat for about 30 years. Up until the 70s. And then from the 80s, it continues warming again. And if you draw a straight line through it, it's like, that's your global warming. But if in our rural one, we're getting something similar. It's noisier because we've less data. But we find from the 1880 or the late 19th century up to the 40s, it's warming. But then from the 40s to the 70s, it's cooling. We only have the data for the Northern Hemisphere because it's very limited rural data for the Southern Hemisphere that covers more than a century. Anyway, from the 40s to the 70s, it's cooling. And then from the late 70s to present, it warmed. And in our estimate, it was about as warm at present as it was in the 40s. You know, you could debate which is higher or lower, and you know, things like that. In some regions we're warmer, somewhere it's colder, and things like that. But the other problem that we found is that the TSI, total solar irradiance data sets that they were using, they all said the same thing. So they had, if you're viewing this, if you're able to see it, we plotted them here in solar output reaching the Earth distance, and in watts per meter squared. And you can see, if you can see the screen, you can see it goes up and down a little bit, wiggles around at around somewhere between 1365, 1367, goes up and down, but not a whole lot happens. Tom, would you agree with that assessment from what
I
you're
would.
seeing?
Yep.
Okay. Yeah, so we said, but look, here are some other estimates that are also published in the peer-reviewed literature that are available. And we said, well, hang on, these are showing different trends. And in particular, we were struck by one. This was Willie had been looking at this since the 90s, and he had noticed this was Hoyt and Shatton, 1993. So Douglas Hoyt and Ken Shatton, in the early 90s, they were one of the first groups to start trying to estimate long-term changes in total solar radiance. And Doug Hoyt was on the team, one of the satellite teams, the very first satellite, Nimbus 7, that was monitoring solar output. It started in 1978, and Doug Hoyt was on that team. And then in the 90s, he started looking and saying, can we go any further back than the satellite era? And he started finding solar proxies. And he actually, to the extent, this is like the irony is that the IPCC estimates, like Wang et al., Vieira et al., a lot of them use Hoyt's data. So they respected Hoyt enough to use a lot of his data, but they didn't like his result. So they used his data to change his. Now, so then independently, the NASA Akram group, after the first satellite was launched in 1978, Nimbus, this was from, I think it was NOAA and NCAR, UCAR, Boulder, Colorado, I forget it, but it was the first one was launched. Then NASA decided to get in on the action. In 1980, they launched NASA Akram, which was a higher resolution satellite for monitoring, specifically for monitoring solar activity. And then each satellite only lasts like 10 to 15 years and needs to be replaced. And they ran a series of 3 satellites, Akram 1, 2, and 3, going up to 2013, with unfortunately a gap of like 2 years after the US Challenger tragedy, which meant that like after, I think it was 1986, the Challenger, when that exploded, there was a kind of a hiatus on launching any satellite until it was figured out what was happening there. And then, so unfortunately, Akram 1 had just stopped working by the time Akram 2 was launched, which is unfortunate, but so it's called the Akram gap, and that's a controversial thing. Anyway, the Akram team, they analyzed the data, and they ended up, so in 2014, Akram group had taken the Hoyt and Shatton estimate, and they'd updated it with their Akram satellite to go all the way up to 2013. And you can see it's this one here, the yellow dashed line, if you can look at the screen. And then there's other estimates, Shapiro et al., Bard et al. But we just said, let's look at this one. And if you look, so if it's audio only, unfortunately, you can't hear it. But Tom, what do you think? Does it look like the dashed line there is the Hoyt and Shatton's estimate of solar activity, and the colored red-blue thing is our estimate of rural temperatures for the Northern Hemisphere? And like, to me, it looks like they could be related.
Yeah, it absolutely does. I can't wait to tweet this out. I have not seen this image before.
Okay. So that's it. Okay, so look, we've been talking for a good while. So that was our 2015 paper. I'll tell you, if you go back to this, that was 2015 paper. So we've published another 11 papers since then, peer-reviewed papers, of course. You know, we still have those non-peer-reviewed papers as well that I still stand over, and I'm happy with the conclusions of them, and I'm happy to talk about them and discuss them. So
Okay.
if you want to kind of ask questions on, because
Okay.
I've been talking.
No, it's been,
yeah.
no, this has been fantastic. Okay. I'll just ask you, I don't know if it's a fair question, but what % of the warming since 1850 do you think was caused by humans?
So how do you calculate the warming since, do you use urban stations?
Yeah, I guess there's all sorts of assumptions there. Just the assumption out there is it's been a little over 1 degree centigrade, but do you think that number is even close to correct?
Well, I think that technically the urban stations are recording genuine local climate change. If you drive into a city or you cycle in and you get a thermometer and you measure it, as you go into the city, the temperature on average will increase. And then when you leave it, it'll slightly cool. When you get into parks and cool areas, it'll get a little bit colder. It'll still be warmer than the surrounding area typically. But you have, it's what's called an urban heat island. Okay, so these are genuine climatic changes, and they are definitely human caused because they're caused by human activity, urbanization. The percentage of the landmass that is urban is depends on how you define it. You could define it anywhere between 1% to 4%, something like that. So that's definitely, that is an urban effect. So I would argue that a large chunk of that, of the global temperature, the global warming, is due to oversampling of that 1 to 4% urban areas. But that, so it's oversampling the percentage of urban warming in the global temperature estimates is far larger than the 1 to 4% that it should represent. Does that make sense?
It totally does.
Mathematical or whatever. So yeah, so that bit there is explains, you know, that's like so that is human caused climate change. And this is a problem. The percentage of the population that lives in urban areas is steadily increasing. It's now, it's since I think it's like 2011, it crossed over to be more than 50%. It's now like, you know, 55%. I forget the exact figure, but it's increasing over time. More and more people are living in urban areas. So the local climate that they are experiencing is urban. And so if people are, and interestingly, this is like interesting for US. This is something that we have been meaning to write a paper on, because our preliminary analysis is showing, if you look at the areas, the most urban areas, which are experiencing the most unusual climate change, because remember I said the US has a lot of data. If you look at the rural areas, you can see a very pronounced warm period in the 1930s, 1940s. It's the Dust Bowl era. Like historians are, you know, you've lots of books written about it. John Steinbeck, you know, it was like a tragedy, the Dust Bowl era. Google Dust Bowl era, and you can read up on it. That dominates in the rural areas, particularly the Midwest. But you know, you can see that it was hotter in the 30s, or at least comparable, and drier in the 30s. So in rural communities, the US so far, our preliminary analysis, our non-peer-reviewed papers, and some work that we have in preparation, but again hasn't been peer-reviewed. But even in our peer-reviewed, the one we were saying, rural US, we're finding it was about as warm in the 30s, 40s as present. About, it's not the similar thing. In the cities, it's the hottest on record, without a doubt. It's like you go to New York City, Central Park Station there, you look at it, it's continually rising up. You go to LA, you go to any of the big cities, it's the hottest on record. Interestingly, what we've found is that, because you guys have in my opinion, horribly partisan politics with your two-party system. To me, I don't understand. My experiences over there, it's like, it seems to me, I'm joking, but it seems to me almost like if you become a Democrat, they send in the post, this is what you believe. And then they have another one. If you flip it over, it's a red sheet. And that's what they send out to the Republicans of Europe. And it's the exact opposite on everything here. The sky is blue, the sky is green. It doesn't matter, it's inverted. But intriguingly, if you look at the Democrat Party, they believe that global warming is mostly human caused. And quite a few of the Republicans as well. But you'll find a lot of Republicans think it's not that unusual. Maybe there's maybe there's some human activity, but it's also climate has always changed, things like that. So we've done some preliminary analysis of just mapping areas devoted for say Biden in the 2020, for Clinton in 2016. And we go back, we still have to go back further. But the ones that voted for the Democrat candidate, they're generally more urban. And for them, they genuinely are experiencing unusual climate change that has not been experienced, that is human caused as well, that in their generations and previous generations. Whereas the ones that voted for the others, they actually are saying climate change is natural, and they are correct. So their local climate, so the ones that voted most strongly, the districts that voted most strongly for the Democrats, their local climate change that they have experienced over the last century is unusual and unprecedented. The ones that voted for to the Republican candidate, they actually, it's kind of cyclical for them. So
okay,
does that answer? And we just have the high resolution data for the US. We unfortunately, that's what I was saying. We're continuing work to try and look at it. And
so it's kind of the same question, but I'm going to phrase it in a different way. Let's say that somehow you had a perfect weather station in the middle of nowhere, 100 miles from anything in South Dakota, and you had it in 1850, and you took temperatures perfectly all the way till now. How much warming do you think that station would show us?
Well, the 1850 seems to be at the end of what's called the Little Ice Age, or the middle of what's called the Little Ice Age. The problem here is we're going from a period, or from using thermometer records for the most recent part, and the further back you go, you have to rely increasingly on what are called temperature proxies, so tree rings and ice core sediments and lake sediments and things like that. So when you look at them, a lot of them suggest that the mid to late 19th century was relatively cold, Little Ice Age period, and that term is generally accepted. The debate is over the magnitude. So yes, it's warmer than it was in the Little Ice Age, for sure. My question though is, how does it compare with the 1940s, or how does it compare with, like, in the instrumental record? And what I would say is, it's definitely warmer as well than the 1970s in the Northern Hemisphere. Most of the analysis that we have is for the Northern Hemisphere. We're doing work trying to look at the Southern Hemisphere, but the data is more limited there. So it's warmer than the 70s. It's warmer than the late 19th century. But how does it compare with the 1940s, 1930s, 40s? I don't know. It looks kind of similar. Some regions, it looks identical. Other regions, when you just average all of the stations, this one could be a bit warmer. The recent era, it might be warmer. When you average the raw data, it's colder. But then we start getting into these non-climatic biases because we don't have that station that you're talking about. And also, you mentioned really what you want is one in South Dakota, one in each of the states. You want one in Europe. You want one, and ideally, you want to have free-floating buoys, these in the oceans, which we've had a decent network in the Argo buoy water sea surface temperature measuring things. We've had a decent one since 2004 or thereabouts. But if you go further back in terms of ocean temperatures, you're relying on ocean liners passing through a particular region and deciding to take some measurements there on the right day to, and do something like that. So, yeah, I don't know if that answered your question or not.
No, that is very good. Okay, so any other points you'd like to make for this go round, or otherwise we'll wrap up, I think, here.
Okay, well, there's lots that I could talk about, I guess, but one thing that I should say, this just to wrap up, but it may be a long thing, is that at the moment there's been increasingly we're getting a problem with the media coverage and journalism. So if you look at in the old days, post say World War II, we used to have journalism naturally, without any check, journalism veers towards propaganda. The propaganda of the editorial boards, so in the very old newspapers, you were getting one newspaper believed something, the editor believed it, and so you'd only hear that story, another believed it. So you had these competing rivalries, and you'd had different rival ones. But then during other periods, like during World War II, you were getting blatant propaganda where afterwards you look and you say, we weren't given information, we were given propaganda. So the journalistic community actively made decisions to try and circumvent that, to try and prevent that. And the concept that they came up with was something called balanced reporting. Now, you can define it in different ways, but I would say just as a minimum, the minimum balanced reporting you could do is you could have editorial bias, you can have journalistic bias. When you read a story, the newspaper or a thing, at the end of the story, in the old days, a decade or two ago, that's the old days, when you got to the end of an article, you were like, oh, this is an outrage, this is but then they would get a quote, a counterpoint from somebody, another perspective, somebody whose opinion was considered of relevance, and that was a different opinion. And you'll get to the end of it, and you said, oh, okay, so there's two opinions. You might still believe one, or you might say, well, I don't fully understand. The bottom line was, you didn't know what to believe at the end of a story. When you read it, with balanced reporting, when you get to the end, you don't know what to believe. And I remember talking to journalists back when balanced reporting was a thing, and you'd have read an article up there, and you'd say, I read your article, very interesting, but what do you think is happening? And they would be delighted. They would say, that's great, I did my job. You didn't know what I thought. You succeeded. Okay, so that was with balanced reporting. Around 2003, 2004, a number of groups started saying they were trying to develop climate policies. They were finding that the UN's policy or scientific information that they could use when they climate journalists did an article describing it, they would then have to go and get a counterpoint. And then like the reader would be going, or they on news or like on a TV or whatever, they get to the end and then they're like, oh, okay. And the public were kind of saying, okay, so it's a bit more complex. So a number of activists said, and activists including and climate professors, and in particular, there's a seminal peer-reviewed paper, Boykoff and Boykoff by Max Boykoff. Boykoff and Boykoff, he wrote a number of papers. I think the first one was 2004. In it, they basically said that providing balanced reporting on climate change was promoting false balance, because the overwhelming scientific consensus agrees with the UN IPCC. And if you're presenting two, that's giving a false balance. So they then said this led to a lot of groups started actively campaigning, soliciting news organizations and saying, on climate change, you cannot do balanced reporting. You need to do what's now called reliable reporting, which is the journalists find out what is the right answer from trusted sources, and then they ask that, and anything that disagrees with that, they don't report on. If it disagrees with, unless they're showing how it's wrong. So that was taken. And so we know there was like Freedom of Information Act, the BBC. This was like, I think you interviewed, was it Andrew Montford? I think he had like on his Bishop Hill blog is where I heard of it. I think there's a guy, Maurizio Moriciba. He I think was involved in it. A number of people found this Freedom of Information Act, or they found out that the BBC had a conference in 2007 in which they made that decision that they were not going to do balanced reporting, but only reliable reporting. And we can see it in other organizations. Our local RTE, this is in Ireland, they have issued statements as well on it, and a lot of news organizations have done that. Now, the thing that I wanted to just say to wrap up is the journalistic community, the media community, appears to have, first of all, there is no longer balanced reporting on climate change that I can see anywhere, other than a few places, a few newspapers, and they're continually smeared for misinformation, because misinformation is balanced reporting. What would have in the past been balanced reporting is now classed as misinformation because it presents more than one side and lets the reader make up their mind. But it seems that following 2016, we had two major upsets to what we call the establishment, we had the US public voted for the wrong guy in quotes, the guy they didn't want, that this was Donald Trump. And then the British in the UK, they voted for the wrong answer on a referendum, Brexit, so they got the wrong answer. And then the establishment, the journalistic community as a whole, seems to have decided that balanced reporting is dangerous. We can't trust the public. And of course, let's not talk about the COVID-19 pandemic, where, the last 2 years and the reporting has escalated things. So now social media as well, since around 2018, social media, all of the Silicon Valley platforms, a lot of them are all saying, we need to stop the public doing their own research, because they might not come to the conclusions that we know are right. And so I would just suggest, how do you recognize propaganda? Because there's propaganda on both sides. Like in the US, you could have, like, say, Fox News has clear Republican bias, ideological biases. CNN clear biases towards the Democrat Party. Okay, so there is propaganda on both sides. You could argue that. I would argue, here's a nice rule of thumb on any story that you hear. Now, if you next time you turn on the news, if you listen or you read an article, at the end of the article, do you know what you're supposed to think? If the answer is yes, then you were not getting balanced reporting. You were getting propaganda. And I don't care what the thing is, whether it's what the ideology or whatever, but it's not balanced reporting. Balanced reporting is applied when you are being informed. The more information you get, the less sure you are of exactly what, because you realize things are more, on any complex issue, you realize there's more nuance. So you're less dogmatic and less certain about the things. But I would imagine most listeners, because I find it when I hear the news, I like, if I listen to the headline, I'm like, oh, I'm supposed to think this. And it's now shifted to every topic. It's now like in Ireland here, I had listened to the morning news came on, and it's like, oh, I'm supposed to believe this, I'm supposed to think this, and this is bad for this is good for this, and I know exactly what I'm supposed to think. That's not been informed. So that would be a suggestion to do. And then you know, if viewers like are interested in learning more about our research, go to ceres-science.com. You can, and if you can support us, give us like $5 or whatever, it helps. If you want to find out more about my specific research, you could go to ronanconnolly.com.
Okay. Yeah, and I'm going to include those links in the show description,
okay,
so people can click on those too. All right, I think we're good.
Okay.
So thank you very much. I really appreciate you taking the time, and I hope we can do it again sometime.
Okay, thanks, Tom. And
thank you very much. See you next time. Bye.
It was a pleasure.